All right, hello once again, Jeff Scott of Rankin Technical College, and as part of my never-ending quest to make things easier for my AWD1000 web development technologies and AWD1111 database-driven database, whatever it is, the database web development class, I've created a series and still am creating a series of video presentations based on the ebooks of Flavio Copes. This is my 6th of 7. I've done HTML, CSS, JavaScript, ES5 to ESNext, and React. And now I'm in the Node.js. And before we get in, which is what we're going to do now and talk about promises, we're 105 pages into a 189-page PDF. First, let's take a look, because I found this article, and I think it's by Free Code Camp. And it's fairly recent. It's about 1.5 years old. And it says JavaScript Promises Explained. So let's take a look at it. JavaScript is single-threaded, meaning, as it says, that 2 bits of JavaScript cannot run at the same time. They have to run one after the other. A promise is an object that represents the eventual completion or failure of an asynchronous operation and its resulting value. So notice what we have here. Okay, and I'm going to, it's going to be nice and big, but there it is. Now, promises have a resolve and they have a reject. So really, a promise can be in one of 3 states. They put in here pending, fulfilled, or rejected. If it's pending, nothing has happened yet. So you haven't run the code, etc. You run the code. If the code works, the promise is resolved. If there is an error in the code, the promise is rejected. Now, think of it this way. Those of you who are going to be in the AWD 1111 class for fall 2021, all right, you assume you pay your money, that the class will be held. So if you come to class the first day and you're told, you see the instructor there, me, and we get in there and we start lecturing, well, you can kind of look at it that the promise that was made to you by Rankin, that you pay your money and we're going to have this class, was resolved. All right. But let's say you're the only student who signs up for the class and they decide they're not going to have the class because with only 1 student, they're paying the instructor more than they're taking in from 1 student. Let's just pretend that's the case for a second. Then the promise that you were given has been rejected. So again, a promise is either resolved or rejected. All right. So it says here a promise exists in one of these states, pending, in its initial state where it has not been fulfilled. Again, typically this is called resolved, and it's not been rejected yet. So fulfilled, what typically is called resolved, means that it completed successfully. Rejected means it failed. So as it says, the promise object works as a proxy for a value not necessarily known when it's created. All right, it allows you to associate handlers with an asynchronous action's eventual success or failure. This lets asynchronous methods return values like synchronous methods, rather than immediately returning a final value. The asynchronous method returns a promise. In fact, you quite often use what's called promise chaining. As it says, that's when you take several asynchronous calls and you synchronize them one after the other. This allows you to use the value from the first promise in later callbacks. And the way that I was taught chaining, not even so much with promises, but the idea is you've got a series of operations where there's a very good chance that if you've got, say, 3 operations, that you want to use the output from operation 1, if it succeeds, as the input to operation 2. And then you want to use the output from operation 2, if it succeeds, as the input to operation 3. All right? The way that's done is with these dot thens. So notice there's one and there's another one. There are 4 static methods in the promise class. We've already talked a little bit about promise.resolve and promise.reject. There's also promise.all, where you can take a bunch of these different operations, put them together, and promise.race, which typically does the same thing as all, but as soon as something finishes, you'll get some kind of a response back. So, when writing promises to solve a particular problem, as it says, you can chain them together to form logic. All right, so what does this mean? Well, when we look in here, what do we have? We've got, it looks like at least, part of a simple calculator. We've got add that returns a new promise. So it's assuming you've got 2 numbers that were passed in. And then we're going to add the 2 of them up. If there was a sum, you'll resolve sum. In other words, it worked. Otherwise, you say could not add the 2 values. Maybe what you passed in there, one was a number and one was a string, or they were Booleans or whatever. Subtract does the same type of thing, but instead of adding the 2 values, you're subtracting the second from the first. Then you've got this promise chain. So notice we're calling add 2. So that should return 4. And then we're calling subtract added 3. So that should be the 4 and 3, so there should be 1 in there. All right. Then we're calling add, and we're taking that 1 that we had, and we're adding 5 to it, giving it 6. Then we are taking that 6, multiplying it by 2, which gives us 12. And finally, we say what the result is. And as it says, if at any time during this we've got a problem, we're going to console log out whatever the error is. As it says here, this is useful for following a functional programming paradigm. By creating functions for manipulating data, you can chain them together to assemble a final result. If at any point it's rejected, you can have it skip to an error handler. All right. In recent releases, JavaScript has introduced more ways to natively handle promises. One such way is a function generator. As it says, these are pausable functions. When used with promises, they can make your code easier to read and appear to be asynchronous. It says, here's my first generator. You can see it by the syntax function asterisk. All right. The gen variable that's in there will be declared, will not run, but instead will say that this generator is ready to use. When we run gen.next, it will unpause the generator and carry on. So since this is the first time we've called gen.next, it will run yield1 and pause until we call it again. When yield1 is called, it will return us to this is pretty heavy stuff. All right. Promise.all we mentioned before. So notice we've got 3 promises. So it says that this is going to return a single promise that resolves when all of them have been resolved. So it rejects with the reason of the first promise it rejects. So if cat source worked and dog source worked, but cow source did not work, this basically would fail. All right. So some more articles that are in here. I just picked out one that I thought I liked, like Free Code Camp. I thought it would be a good way to at least get us started with this. So let's jump back into here. Introduction to promises, how they work, which JavaScript API uses promises, how to create promises, how to utilize or consume promises, how to chain them together, how to handle errors, promise.all and promise.race, and some common errors. So some of this you've already heard. So as it says, a promise is commonly defined as a proxy for a value that will eventually become available. Although around for years, promises have been standardized and reintroduced, I guess, really in 2015. And now they've been not replaced because you're still going to see callbacks in code. You're still going to see promises in code. And really with async await, It's just an easier way to write promises. We'll look at that shortly. All right. Async functions use promises API as their building block. So understanding them is fundamental, even if you're going to use async instead of promises. Again, you'll oftentimes see things like it'll say that async and async await are syntactic sugar that have been put up on promises. In other words, kind of window dressing, all right, that are put on to make promises easier to understand. Once a promise has been called, it starts in a pending state, meaning that, okay, the function's going to continue until it either is resolved, meaning it's succeeded, or it's rejected. So while it's in the pending state, the caller functions waits for it to either return resolved or rejected. Which Java API uses promises? Well, one of the key ones is this one right here, the fetch API. We're going to be going through an example of this in class. All right. We may have gone through this last semester. I don't remember, but we're going to go through it really slowly in class. All right. You want more on service workers? Here's the tutorial on service workers, again, by Mr. Copes. The Promises API exposes a promise constructor when you initialize it. And make sure when you do this, you say new promise. Don't just say promise or you're going to get an error. And notice here, is it done yet? Resolve or reject? If done, here's what I built and we're calling resolve. We're telling it it's been resolved. Otherwise, it's been rejected. So it either succeeds or it fails. All right, so as it says, the promise checks the done global constant. And if it's true, we return the resolved promise, otherwise the rejected promise. Using resolve and reject, we can communicate back a value. So to consume this, it says running check if it's done will execute the is done yet. All right, and there'd be some code in there to do something. And waits for it to resolve. Then using the then callback. Otherwise, if it's an error, you resolve that here. Already mentioned before, you can chain promises together. So as it says, a promise can be returned to another promise. Or again, you want to use the output of the resolved promise as the input into your next promise. A great example, it says, is given by the fetch API. All right, so here's I read a lot of the stuff that Copes has put out there. I just think that he does a pretty good job of explaining things and explaining it in a way that, at least as far as I'm concerned, makes sense. You may agree, you may not agree with that. I don't know. All right. Okay. So here's an example. So response, and if the response worked, all right, we're basically going to return another. A promise resolve or a promise reject. And this is where the chaining takes place. Then we want to go on and do this. And if it fails any place, we want to do this. All right. It says in the example in the previous section, we had a catch that was appended to the chain of promises. When anything in the chain of the promises fails and raises an error or rejects the promise, the control goes to the nearest catch down the chain. Now, notice we're doing the same thing here, too. Okay. If inside the catch you raise an error, you can append a second catch to handle it. So in other words, all right, if you put some information in there that's saying, hey, this is how we want to handle an error, But if that produces another error, you can put a catch in for that one. And it's in the same way as using the try-catch mechanism that we've used in other languages before, like C#. All right, where it's possible when you use a try-catch that catch can actually fail as well. All right, so you can put another catch in there. All right, promise all, as it says, if you need to synchronize different promises, promise.all helps you define a list and execute something when they're all resolved. So it's going to go in order, and if it's resolved, it'll do this. It says you are not limited to using fetch. You can use anything with this. All right. Promise.race, as it says, runs when the first of the promises you pass to it resolves. And it runs the attached callback just once with the result of the first promise, all right, resolved. Now this uncaught type error is what I mentioned before. If you don't say new promise when you create this, if you just say promise and you leave off the word new, that's typically how you're going to get that particular error. All right, so we have now talked about callbacks. We have now talked about promises. All right, the newest way, so you notice ES 2017, so we're talking now about 4 or 5 years old, 4 years old, I guess, is to use async await. And we'll talk about that in our next lecture.